Commercial diving is one of the most dangerous occupations in the world. Being trapped under the weight of hundreds of feet of ocean is the nagging dread of every diver, as they are attached to the surface with a single lifeline umbilical cord. When the integrity of this link is in jeopardy, the consequences are devastating. This is the fatal breakdown of the Wild Rake diving accident. Infabco Diving Services had just received the contract to repair an oil transfer station in the North Sea. They were a commercial diving operation which had just acquired a brand new diving ship, the Wild Rake. The final details were still being seen to in manufacturing, so they would be rushing this ship out to start their repair contract immediately. In this repair plan, the Infabco Diving Company would be reinstalling a riser and buoy in a filling station for an oil platform in the Thistle oil field. This filling station was called a single anchor leg mooring or SALM, and it allowed tankers to pull up at a safe distance from the platform to fill up. During this first group of dives, they had to deal with a number of unexpected issues with the new saturation diving system. This system included a diving bell to transport divers to the necessary depths to work on welding, fitting, and repairing the SALM parts. This bell would be pressurized to match the pressure on the outside so that the two divers could work and rest in shifts deep in the ocean. The Wild Rake was equipped with a saturation diving system. This allowed the divers who were working hundreds of feet below the surface to stay under pressure inside the ship, to avoid the long decompression schedule. In recreational diving, a diver might spend 10 minutes at a deeper depth, then have a slow ascent with stops at several depths along the way to allow the gas that was pushed into the bloodstream a chance to slowly gas off, avoiding the dangerous consequences of decompression sickness. If you return to shallow depths too quickly, the gas leaves the bloodstream suddenly and causes air bubbles which are painful and debilitating, and in extreme circumstances can be deadly. Commercial divers have to spend long stretches of time at deep depths to complete work projects, which is problematic for companies trying to do repairs or installations on the seafloor. The saturation diving system is a clever solution to keep the divers safely at a consistent amount of pressure for extended periods of time. In this case, the divers would be under saturation for 28 days at a time. This would allow them to work in shifts to complete the contracted repairs while avoiding the slow 5-day process of decompression. On the Wild Rake, the diving bell was attached to 2 living chambers. This allowed 6 divers to be in saturation at the same time. 2 divers would go down in the bell to work on the job, while the other 4 would eat, sleep, and rest. The quarters were cramped, but the job paid well, so divers were willing to sacrifice their comfort and risk their safety to support their families back home. There was a team dedicated to monitoring the air quality, temperature, and pressure of the saturation chambers, and another team dedicated to the bell. The men were all facing the same danger in such a high-pressure environment, but the guys in the bell faced additional risks by being alone nearly 500 feet below the surface. The Wild Rake had been working on the project for nearly a month. They had successfully completed 29 bell dives, working on various parts of the connection and installation. The 6 men currently under saturation on the Wild Rake in August of 1979 had only just started their 28-day schedule. Richard Walker, Skip Guyel, Lacey Laren, Dave Mitchell, Roger Palmer, and Dave Boyd were on the 9th day of saturation. They had moved the completed SALM unit next to the Thistle platform and were going to attach it to the SALM base. When the previous team came out of saturation, they shared some of their issues with the brand new chamber and bell. Their 17 dives were the first for this brand new ship, so they discovered some problems to manage and mistakes to fix. One of the first discoveries was that the bell couldn't be lifted up into its cradle to be launched. The swivel connector was too long for the cradle that was on this ship. It seems like a fundamental design standard that was missed, but Brian Masterson, the owner of Infabco, decided to pull the swivel off the lift wire and reconnect it with 2 shackles instead. It did solve the fit problem, but was a poor substitute for the necessary swivel action. The torque and impact on the shackles was not appropriate, but it was a temporary solution for this dive trip. Even though there were some questionable design features for this bell, the new group entered saturation with confidence that their teams on the ship would keep them safe. So on this day, August 7th, Richard and Skip were up for their bell shift. It was 11 p.m. and the men were suited up in their hot water suits to enter the bell. These suits were an essential component of saturation diving. One of the many tubes fed through the umbilical cord to the bell contained hot water. The water flows through their scuba suits to keep them warm. The temperature in the North Sea was 40 degrees Fahrenheit. The umbilical also had tubes to provide their breathing gas mixture and electricity, as well as cords for depth gauges, communications, and video. The bell was designed to be sealed with a double-door system that would allow the pressure inside to be raised or lowered to match the depth where the work would be performed. This pressure would also allow the hatch doors to be opened without flooding the interior with water. One of the two men would lower themselves into the water and become the lockout man, performing the work outside the bell. The other man would remain inside as the bellman to monitor CO2 levels, air pressure, communications, and the umbilical of the outside man. At 11:40, Richard slipped into the dark water to start the night's work. He performed many of his tasks and was now using a video camera to show the base to the dive superintendent up on the ship. After a few passes with the camera, he turned to return to the bell. What he saw was confusing for a split second, but then it became strikingly clear. The bell was much closer to the sea floor and was hanging at a 45-degree angle. He directed his camera to the bell to show the topside team as he instantly moved to the bell, knowing that he had to get inside before it got any closer to the bottom. In one of the unusual design flaws of this bell, there was no frame to hold the bell off the sandy bottom. If it needed to be set down, the bell would directly rest on the ground without any space to operate the hatch door. As Richard moved to the bell, Skip was inside cracking the gas valve open to increase the pressure inside the bell. Since the entire bell had dropped 25 feet, the icy water was starting to rise up the trunk. It was 2:45 a.m. when Richard informed the topside of what he saw. The lift wire was no longer connected to the bell. He came up the trunk and pulled the inner door closed as he and Skip tried to figure out exactly what had happened. Up on the ship, the bell team realized that the lift wire had broken and the bell was actually dangling by its umbilical. The video screen had gone black and no communications were coming from the bell. Out on deck, another huge problem was revealed. Hot water was spewing all over the deck from the umbilical. This was another design flaw that had been revealed a few weeks earlier when the hot water line cracked and broke inside the umbilical. The wrong kind of tubing was used and it quickly sheared under the kinking and folding of the umbilical. This problem had been solved by adding a new hot water line outside the umbilical and just taping it in place around the existing line. When the lift wire broke, the instant pull on the umbilical caused a compromise in this external tubing. So now they were without communications and a diminishing supply of hot water. But the gas line and depth gauges still seemed to be working properly. The bell team could see that the internal pressure of the bell had increased, indicating that the guys were both inside, and they had increased the pressure to seal the door shut. For now, this was a somewhat stable situation. The air supply was good, and they also had emergency air tanks attached to the bell. Normally in this situation, a diving ship would institute its secondary bell recovery method. In order to dive commercially, ships were required to have a primary and secondary means of bell recovery in place. In another devastating flaw of design, the secondary method had to be disabled just weeks before. The ship was designed for the bell to be launched through a moon pool on the deck's surface. Unfortunately, the designers weren't experienced with the rough North Sea, nor the normal pitfalls of dropping a bell down a pool in the middle of the deck. Because of the storms they had been facing, the bell had to be dropped into the water over the side of the ship. There was a nice crane system called a davit that could swing out over the water to launch the bell that way. Unfortunately, when the clump weight was hanging from the bottom, it couldn't clear the deck railing. The clump weight was the proper bell launching mechanism, but it also served as an emergency recovery system in case the lift wire broke. This system included a heavy weight lowered on 2 guide wires. Once this weight hit the seabed, the bell could be lowered to the proper depth on the guidelines. This made for a stable path for the bell. Without a lift wire, the clump weight could be pulled back up by its guide wires, and the bell recovered in a fairly routine manner. The decision was made to just remove the clump weight system in order to clear the rail and launch the bell into the water. They had been using this method for weeks, but made no efforts to rectify this dangerous situation. Now that Richard and Skip were safely in the bell, with no lift wire or clump weight to bring them up, options were being discussed on how to recover the bell safely. Back in the bell, the men were following protocol. They were locked in the bell, but had no communications with the surface. They continued to try to send messages, but only heard static over the radio. The air and hot water were still flowing, so they just needed to sit tight and wait for a recovery operation to retrieve them. Suddenly, they felt a jerking heave, and then another. They were in complete disbelief, but it was obvious that they were trying to recover the bell using their most precious lifeline. Skip yelled into the comms, "Put us on the bottom! Put us on the bottom!" over and over. He had no idea if it was getting through, but he was desperate to protect the only connection that was keeping them alive. On the Wild Rake, the diving superintendent Holmes was under tremendous pressure to figure out what to do to recover the bell. He was well aware that the clump weight was not in service, so they would have to rely on the only other method available to him: the umbilical. There were some bell systems where the umbilical could be used as an emergency recovery method, but the Wild Rake was not necessarily one of them. The company that had manufactured this ship had missed some important details about saturation diving, bell construction, and limitations in the operating conditions. Relying on their claim that the umbilical hydraulics could handle the load was not reassuring. They had manufactured an umbilical that had already failed with improper materials, so this was a risky choice. The owner of Infabco, Brian Masterson, was with Holmes as they consulted the most experienced dive operations men to discuss alternatives. The safest choice would have been to lower the men to the seabed to relieve the pressure on the umbilical, then request another ship to send their bell divers down to reattach a lift wire to the top of the Wild Rake bell. At 2:57 in the morning, they reached out to the nearest dive ship, the Stena Welder. They only stated that they had an issue and to stand by for potential assistance. Ultimately, they decided to try the umbilical first, despite having another reasonable plan proposed. During this time, the men on deck were trying to repair the hot water line to limit the amount that was being lost. This work was stopped when they received the order to fire up the hydraulic motor on the umbilical wheel. They were stunned by the request, but were in no position to challenge the owner and dive superintendent. The umbilical started pulling tightly and wrapping around the wheel, but in just moments, the stop order was given. The men were in complete disbelief. The umbilical was splitting open, and the individual wires and tubes were now jammed in the side of the wheel. They were deeply jammed, and hot water was now spewing from this meat grinder. This should have been the time to call in assistance and hope that the lift wire could be reconnected by the Stena Welder team. But that's not what Masterson and Holmes decided. They were still intent on using the umbilical to recover the bell. The Wild Rake had a crane on deck, and they were going to use it. They repeated the effort to pull the umbilical to lift the bell up to the ship. As soon as they started, they were met with disaster yet again. The umbilical was not only splitting apart, the tubes and wires were literally snapping and popping apart. During this crucial moment, a faint transmission could be heard coming from the bell. The voice strained, requesting the bell be set on the seabed. Skip had finally been heard. Inside the bell, Skip and Richard were shocked that the bell had been yanked around by its umbilical. But when the movement stopped, they knew that something terrible had happened. The lights had gone out, so they switched on the emergency battery power to take stock of their situation. Clearly the umbilical had been damaged. Only 2 lines survived the trauma, the main gas and the topside internal depth. It was now 3:45 a.m., and the clock had officially started ticking. Their hot water line had been severed, and their most pressing issue would be hypothermia. They followed procedures and opened their survival suits, which turned out to be foil blankets instead of the full body suits they expected. At 4, the Stena Welder was finally asked to make the rescue. The 2 ships went back and forth with instructions and equipment, but by 5:45 the issues were resolved. 2 Stena Welder divers, Eddie Frank and Phil Casey, were heading down to connect the wire and make contact with Skip and Richard. Originally, the Welder group planned to lift the bell themselves to help facilitate the transfer, but Brian Masterson had something different in mind. He directed them to connect the Wild Rake's own lift wire to the bell, and that he would be the one to rescue the men. It seemed like a ludicrous suggestion to the diver superintendent on the Stena Welder. They were directly over the bell location for the safest lift angle, and the Wild Rake would have to reel in the bell at a 45-degree angle, which is completely unheard of in commercial diving. It went against all best practices, but Masterson wasn't a diver, he was a businessman. His compounding mistakes seemed to continue without anyone able to effectively object. The welder's bell was down at the target area, but had to search around for more than an hour to even locate the bell. When the Wild Rake crew gave the coordinates, they forgot that they had moved the bell away from the Salm base hours earlier, but forgot to update the location coordinates. This might not have been a problem if the bell transponder had been in place, as it had been for the previous 29 bell dives. The very night before, when Skip and Richard were being lowered into the North Sea, The transponder came loose from the outside of the bell. Instead of pulling the bell back and properly attaching the location device, the deckhands were instructed to just cut it off. They were in a hurry to get the bell in the water after many delays. Now that they are in this dire situation, where every minute matters, this waste of time was unreal. Incorrect coordinates, no transponder for locating. It was left to Frank and Casey to walk in a wide arc around their bell to find the lost men. In a terrible stroke of bad luck, the Stena Welder was repairing their bell just before the request for assistance was made. So the lights outside their bell didn't work, and the comms from diver to bell were also out. This made the entire operation extremely cumbersome and dangerous for these men. At 6:44 a.m., Casey entered the water to start the search, and more than an hour later he finally made contact with the bell. He tapped on the window with his knife handle and was relieved to see the frantic movement inside. He saw a face and 2 thumbs up in the porthole. It was 7:55 and they were confirmed to be alive and well. During this search period, Richard and Skip had no idea of what was going on. They had been waiting without communications for over 3 hours. After running through the options, they decided to resort to the last emergency action available to them. Outside of every bell, there are drop weights attached to weigh down the bell because of its natural buoyancy as an air bubble. In an emergency situation, these drop weights can be released to allow the bell to make a quick ascent to the surface for recovery. The key factor that makes this recovery possible is that both men must be locked inside the bell under controlled pressure. Otherwise, this quick ascent would be certain death. There had recently been several deaths because of accidental release of drop weights. If one man was outside the bell working, then he would be dragged to the top in a grisly certain death. These recent events were fresh on the minds of the Wild Rake crew. Just weeks before, they had been directed to add nylon ropes to tie the drop weights to the outside of the bell to avoid accidental release. The problem with this is that divers would need to go outside the bell to cut the ropes before they could activate the release mechanism. Skip and Richard were aware of this unorthodox system and knew that one of them would have to go out to cut the ropes before they were too hypothermic to make the dive. There was one devastating obstacle. They were sitting on the seabed with no way to get out. There was a slight tilt to the bell, so the trunk was not completely flush with the sandy bottom. Richard was able to contort his body to reach around the opening with his knife. His arm was cut up from the strain against the sharp metal edges, but he was able to free one of the 2 weights. The other side was an impossible task. He was not able to reach the ropes for the second weight because of the tilt of the bell and the hinges on the outer door. This was the last option within their control, and now they were faced with an unknown weight for rescue. The topside meters recorded that the bell was repressurized, and drop weight releases were opened between 7:10 and 7:50. They had just locked the hatch and resealed the door when Phil Casey knocked on the porthole. The men must have had a surge in hope that they were found and help was just outside the bell. It had been 4 hours since they lost their heat, so hypothermia was setting in. They huddled together to try to reduce the uncontrollable shiver and wait for rescuers to get them out. Finding the bell was just the first step in a difficult procedure for Casey to perform. He had to bring the lift wire to the bell and get things properly secured in a dark ocean all alone. The bell lights and his comms weren't working. Thus many trips had to be made back to the bell to communicate with the surface. The Stena Welder above was being heaved around by the ocean waves, which made the bell orientation and location constantly changing. Casey had to start anew each trip to figure out what direction the Psalm Base and Wild Rake Bell were located. The difficulty of his task cannot be understated, and he was nearly hypothermic himself trying to save these 2 fellow divers. At 9:02, he checked on the divers through the porthole. They were making very frantic hand movements, and he could see their complete desperation to be saved. After several more trips back and forth, the lift wire was finally connected. It was 10:10 when Casey took another look at the men and was relieved that they were in fact still alive and alert. It had been over 7 hours since the wire broke and at least 5 hours without hot water. The men were certainly hypothermic, but hanging on to hope. After several more hiccups, the bell was finally connected to the Wild Rake, and they were ready to recover this bell and save the men. It was 11:40 when the wench started turning, but within just minutes, another devastating mistake would destroy the tenuous connection. Masterson's choice to drag the bell at a 45-degree angle, instead of just moving the Wild Rake directly overhead, would cost them everything. As the bell began moving across the seabed, it got hung up. but Masterson told the crane operator to shake the crane back and forth and full heave on the line. The rest of the deck crew was stunned. This is not how diving was done. Everything should be cautious and measured, checked and rechecked. Jerking on the only lifeline, without repositioning the ship or sending down divers to look at the issue, was reckless. Their worst fears were confirmed when a loud boom and snap of the line caused it to go slack. It was 12:20 and the bell was lost again. Inside the bell, Richard and Skip must have known exactly what happened. It had been 8 hours since the bell had lost heat, and 2 hours since someone had last peered through their window. They heard the metal clank of the wire being attached, and now the bell was finally moving. The overwhelming relief must have revived their hopes for rescue. But then the unthinkable. A loud clash of metal brought the bell to an abrupt stop, and then after a moment, the thump of the wire breaking, and the release of the bell back to the seabed. Richard and Skip were hypothermic, exhausted, and nearing death. Each breath was a chore to pull the cold air into their lungs. The men knew that it had taken hours of freezing silence, waiting for that wire to be reattached the first time. The sinking realization that they just may not survive for long enough to get the bell out of the water was crushing. The Stena Welder was asked again to locate the bell and check what had happened. Frank spent 30 minutes looking, and finally found the Wild Rake's bell wedged tightly between a pipe and the psalm base. At one, he tapped on the porthole and saw the white face of Richard react. He was drawing hard breaths and slowly opened his eyes to see the face peering in at him. Skip was curled up in his blanket on the floor of the bell. Just as Frank had gotten a look, he was jerked away by his umbilical. The rough seas kept the Stena Welder fighting to stay in position. This moved their bell and pulled the divers uncontrollably. At 3 o'clock, the Stena Welder divers were brought up to the surface after 9 hours in the water. A new diver was sent down to try to rehook the lift wire and get the Wild Rake men out of the water. It was 5 o'clock when he found the bell. He looked inside to find the men slumped over each other on the floor. Skip and Richard had been without hot water for over 13 hours. It wasn't until 7:30 that the bell was finally recovered and brought on board the Wild Rake. Despite a dozen individual heroic efforts to save the men, it would not be. They had survived with no hot water for at least 9 hours. This was an unbelievable feat of the human will to survive. As this event was analyzed over the next several years, the many reckless and impulsive choices were questioned by the professional diving community. Brian Masterson should not have been directing the rescue. There were many well-qualified men who knew the perils well and had plans established to retrieve a separated bell. His mistakes, compounded with others, cost these 2 men their lives. To add insult to injury, he was trying to get the umbilical replaced so that he could send the saturated divers down to complete the job. The 4 men that remained in saturation immediately demanded to start the decompression process, which would take them 5 days. Eventually, the company was sued in Scottish and United States courts, but they were able to evade any real consequences of these actions by claiming that they were not the actual employer of the men. Later, in a UK court, 12 individuals were sued and settled with the divers' families for a small financial payout.